Look here. A solvent whose freezing point is T1 degree centigrade, and when a non-volatile solute is added, the freezing point of the solvent decreases to T2 degree centigrade. So the difference in the freezing point is delta TF, which is equal to T1 degree centigrade minus T2 degree centigrade. Even if the temperature is mentioned in Kelvin, no problem, because the grading in centigrade and Kelvin are of the same. So difference in two temperatures, when the two temperatures are mentioned in degree centigrade or the two temperatures are mentioned in Kelvin scale, the difference is always the same. So this is the delta TF. This delta TF is directly proportional to concentration of the solution. Concentration is expressed in various terms. Concentration can be expressed in molarity. You should know all these expressions thoroughly, and you should be able to convert one expression into another expression. Molality, normality, percentage solution, and mole fraction. Whether you are doing a problem in thermodynamics or ionic equilibria or chemical kinetics or electrochemistry, the fundamental concept of mole is very important. Molarity is the number of moles of solute present in 1000 ml of the solution. 1000 ml of the solution. Whereas molality is number of moles of solute present in 1000 gram of the solvent. See, here it is a solvent. Here it is solution. Normality is number of gram equivalents present in 1000 ml of the solution. You look at the difference here. The volume is mentioned here, but here the weight is mentioned. Here again, the volume is mentioned, 1000 ml of the solution. Number of gram equivalents. Percentage solution can be either volume by volume or weight per volume or weight per weight. So percentage solution can be of so many methods of expression. Mole fraction is number of moles of solute. If you take the mole fraction of the solute, it is the number of moles of solute divided by number of moles of solute plus number of moles of solvent. Number of moles of solvent. So that is why mole fraction is always a fraction. And also the mole fraction of solute plus the mole fraction of solvent will be unity. So whenever the mole fraction of solvent is given, you can directly subtract the mole fraction of solvent from 1 so that you will be getting the mole fraction of the solute and vice versa. But in the case of colligative properties, the delta TF, the depression in the freezing point, is directly proportional to concentration, and essentially the concentration has to be expressed in molality. Molality. So you have to find out the molality of the solution. Molality is number of moles of solute present in 1000 gram of the solvent. Suppose I take W1 gram of solvent, W1 gram of solvent and W2 gram of solute, W1 gram of solvent and W2 gram of solute, and the molecular weight of the solute is M2. W2 by M2 is the number of moles. So these many number of moles are present in W1 gram of the solvent, means what would be the number of moles of solute present in 1000 gram. So substituting all these values and introducing a proportionality constant, you can rewrite the equation like this: delta TF is equal to Kf, the proportionality constant, into W2 by M2 into 1000 divided by W1. So Kf is called molar freezing point depression constant. So when delta TF is known and the weight of the solute and the weight of the solvent and the molecular weight of the solvent are known, then you can find out Kf. Or if Kf is given, you can find out the delta TF. Or when delta TF, Kf, W2, W1 are given, you can find out the molecular weight of the unknown substance. On this, I'm going to do a problem on this. Very simple problem, but you can easily understand. You note down this problem. An aqueous solution what happened? Okay. An aqueous solution freezes at minus 0.186 degrees centigrade. And the Kf of the solution is, the solvent is 1.86. The Kf or Kb or something pertaining to the solvent. And the Kb of the solvent is 0.512. What is the elevation in the boiling point? Question is, what is the elevation? What is the elevation in the boiling point? This is the question. See, first of all, it is an aqueous solution. Aqueous solution means the solvent is water. So the water freezes at 0 degree centigrade, and after the addition of the solute, it has frozen at minus 0.186 degree centigrade. So the depression in the freezing point delta TF is equal to 0.186. So we have to find out the molality. What is the concentration? So delta TF is equal to Kf into molality. The molality is not known. So the molality, the concentration of the solution is delta TF divided by Kf. So that is equal to delta TF is 0.186 divided by the Kf is 1.86. Therefore, the molality is a 0.1 molal. The solution is a 0.1 molal. So what would be the elevation in the boiling point? It is delta TB is equal to Kb into molality. So delta TB is equal to Kb is 0.512 into molality is a 0.1. So it is going to be 0.0512, which means that elevation in the boiling point is 0.0512. That means the same solution will boil at 100.0512 degree centigrade. So this is the new boiling point. This is the elevation in the boiling point. So the depression in the freezing point is given, and the Kf, Kb values are given, and you are asked to calculate the elevation in the boiling point. Benzene and toluene form nearly ideal solution. So at 20 degree centigrade, the vapor pressure of benzene is 75 tar and that of toluene is 22 tar. The partial pressure of benzene of the solution containing 78 gram of benzene and 46 gram of toluene in tar. So this is the question asked. See, first of all, you should understand this question. See, I have in a beaker benzene and I have in another beaker toluene. See, the benzene will get evaporated and the vapors of the benzene will come out. And similarly, the toluene will get evaporated and the vapor of the toluene will also come out. When you take pure benzene, according to the problem statement, the pressure is 75 tar. That is the vapor pressure of pure benzene. The vapor pressure of the pure toluene is 22 tar. Now the problem is when these two things are mixed together. Now I am taking a common beaker in which both the benzene and the toluene are added together. Now the benzene will evaporate and toluene will evaporate, and the region above the liquid surface will contain the benzene vapor and the toluene vapor. What will be the vapor pressure of benzene and toluene now? This is the question asked. When they are mixed together, the vapor pressure of each component will depend upon the mole fraction of that component in the solution. So this is for pure state. Let me say this is P0, vapor pressure in the pure state. Let me say this is P, the vapor pressure in solution. So the vapor pressure in solution is equal to mole fraction of the component multiplied by the vapor pressure of that component in the pure state. This is the expression. So when the mole fraction changes, the partial pressure in the mixture also changes. But this is the vapor pressure of that component in the pure state. If you take this is the, suppose P1 is benzene or PA is benzene and PB is toluene, then the total pressure of all the vapors will be PA plus PB, and the total pressure P will be equal to mole fraction of A into PA0, that is the vapor pressure of benzene in its pure state, and the mole fraction of B into the vapor pressure of toluene in its pure state. Even this equation can also be written as P is equal to XA PA0 plus 1 minus XA, because 1 minus XA will give you XB into PB0. The same equation can be written like this also. So first of all, you should find out the mole fraction of toluene and benzene in the given mixture. So the number of moles of benzene is equal to the weight of benzene taken 78, right, divided by the molecular weight of benzene, which is also 78. So 1 mole of benzene is present. If you want to calculate the number of moles of toluene, number of moles of toluene is 46 gram of toluene is taken, and the molecular weight of toluene is 92, because benzene is C6H6. Okay, for 6 carbons 72, for 6 hydrogens is 6, so 78. For toluene it is a C6H5CH3, so it is 92. One hydrogen is removed and a methyl group is attached, 92. So what you are getting is 0.5. So mole fraction of benzene is 1 by 1.5. So total number of moles of benzene and toluene is 1.5 and the number of moles is 1. So what is asked is, what is the vapor pressure of benzene and toluene? So for benzene, it is PB is equal to 1 by 1.5 into PB0, the benzene, in its pure form. It is going to be 75. So it is coming out to be 50 tar. 50 tar. And for PT, for the toluene, it is 0.5 by 1.5, 0.5 by 1.5 into 22 tar. 22 tar is the vapor pressure in its pure state. So the answer is 3.3 tar. So total vapor pressure will be 53.3 tar. So this is how the vapor pressure. See some threes. Phosphorus is also given. NaH2PO2. Na2HPO3. NaH2PO4. This is another interesting problem which is asked in the NEET examination. Question is, which of the following salts can furnish H plus ions in aqueous solution? So I am dissolving these salts in water. Which one of the following salts will furnish H plus ions, which means that when they are dissolved, which salt will give out H plus ion? That is the question. See, NaH2PO2, it has come from the acid H3PO2. Na2HPO3, it has come from the acid, HPO3 has come from the acid H3PO3. NaH2PO4 has come from the acid H3PO4. If you look at this acid is a monobasic acid, which can give out only one H plus ion, and that one H plus ion is replaced by sodium ion in the salt. Therefore, on dissolution, it is not going to give any H plus ion out, because the other two hydrogens are directly connected to phosphorus. They cannot come out. The structure is like this. This acid is able to give out only one hydrogen. Here it is able to give two hydrogen ions, but those two hydrogen ions are replaced by two sodium atoms. Therefore, this also will not furnish H plus ion.